So an open manometer is going to be just a little more difficult for us to work with. Okay, so again, it's going to look like our closed manometer in that it is a piece of U-shaped tubing. And we're going to have a valve that's going to allow us to attach a container of gas to one end of the tubing. And this is going to be filled with mercury. But in an open manometer, we are not going to seal off the arm on this side. So this is open to the air, which means that when I open this valve, I'm going to have the gas pushing on one side of the mercury, and I will always have the air pushing on the other. So we have some thinking to do. So the pressure on the mercury from either side is going to mean that we are actually measuring the difference in the air pressure and the gas. So an easy way to think about this is we're always going to start with the air pressure, and then we're going to decide whether we either add or subtract the height of the manometer to get the true pressure reading for our gas. So that means we have two different scenarios that could happen. Let's talk about scenario A. So we know this is open because we can see that the tube at the top there is not sealed off. And we can see that we have a difference in the height of the mercury between the two is 60 millimeters of mercury. So we have the gas pushing on the mercury at this end, and we have the air pushing on the mercury from the other end. So we simply have to stop and think, who is pushing harder if we know that when the mercury started, it was at equal spots in the arm? Well, it is clear that in our first scenario, the pressure of the gas is higher than the pressure of the air because the air has gone up higher in the arm that is open to the air. And that is the way we would describe this manometer in scenario A if we did not have a picture to look at it. You'll see that in some word problems that we're going to come across a little later. So the mercury is higher in the arm open to air is looking like the picture we see here in scenario A. So a reminder, we said we're always going to start with the pressure of the air and decide, am I going to add H or am I going to subtract H? Well, if this picture shows that the pressure of the gas is greater than the air, the only way to get a number bigger if I'm starting with the air is to add H. So if I want the pressure of the gas in scenario A, I'm going to start with the air pressure and then add H. It's the only way I can get a bigger number. Okay. Looking at scenario B, we can clearly see that things look a little different. Here again, we have the air pressure, air pressing on this end of the mercury, and the gas pressing on this end of the mercury. A reminder, when they started, they were equal in that column. Okay, so if the mercury is now higher in the arm attached to the gas, so that means it's higher in this arm here, that's what we mean by saying higher in the arm attached to the gas, that must be because the air is pushing harder than the gas. And so we have the gas pressure is less than the air pressure. And a reminder, we said the easy way to think about getting these is always, if I want to know the pressure of the gas, start with the air pressure and then either add or subtract the H. Well, if I know the gas has to be less than the pressure of the air, the only way I could possibly get a smaller number would be if I subtracted H. All right, so let's look at an example here. So we have an open manometer as shown in our picture here with a height of mercury of 60 millimeters of mercury. So when I look at that, I see that the mercury is higher in the arm that is open to the air. And we are told what the air pressure is. So what I want to do when I look at the picture is decide, is the pressure of the gas greater than or less than the pressure of the air? Since it's being pushed up into the column, and that it's higher in that, we know that the pressure of the gas is greater than the pressure of air. So we are going to always, when we want the pressure of the gas, we're going to start with the pressure of the air. And if I need the gas to be a bigger number, the only way to get a bigger number would be to add the height of mercury, right? So our air pressure is 98.0 kPa, and the height of mercury from our picture here is 60 millimeters of mercury. Right, so I hope you notice, and that's 60.0, I hope you notice that we can't just add these because we have unlike units. So they want to know the pressure in kPa, so we'll keep our air pressure at 98.0 kPa, and we will convert our 60 millimeters of mercury to kPa, and we have our conversions up top there to help us out. So we want the 760 millimeters of mercury in the denominator, 101.3 kPa up top. And good old Euro, we have two different rules for rounding here. We'll do our conversion here first. This will want to 3 digits, and 60 times 101.3 divided by 760, rounding it to 3, I get 7.79 kPa for H, if we make our unit conversion there. Now we're going to add our 98.0 plus 7.79. Following our addition rule, we haven't used that for a while when following sig digs. We're looking at decimal places, so 98.0 is 1, 7.79 has 2. And if we add those two together, that would give us 105.79, rounded to 1 decimal would be 105.8 kPa. All right, let's look at another example problem here. And we're going to be asked again to find what is the total pressure of the gas in kPa. So again, the key to this type of problem is deciding whether or not the pressure of the gas is higher or lower than that of the air. So again, we have the air pressing on the mercury from this end and the gas from this end. So when I look at the mercury in my column, I can see that it's pushing, the air must be pushing harder because it is going up and into the other arm. So we would describe this as the mercury is higher in the arm connected to the gas. So that means in this scenario, the pressure of the gas is less than the pressure of the air. So remember, we said that what we want to do is always start with the pressure of the gas and then decide whether or not we are going to add or subtract that H. So I'm going to try something a little better. It was so messy on that last time when I was trying to write everything there. So here we're going to, we already said that we know that the pressure of the gas is less than the pressure of the air because of what our column looks like. So to get the pressure of the gas, you always start with the pressure of the air, and if the pressure of the gas is less than the air, the only way to get a smaller number is to subtract H. Otherwise, I'd get a bigger number. All right, so now we just need to pull those values out of our word problem. So the pressure of our gas is going to equal the pressure of the air, they tell us in the problem, is 98.0 kPa. And we are going to subtract H, and H from our picture there is again 60 millimeters of mercury. Hopefully you recognize that we have two different units. We have kPa for our air pressure and millimeters of mercury for the H. So I have to have like units before I can do anything. So I'm going to keep our 98 kPa. And we are going to subtract. Let's go down to the bottom here. We have a little more room. I'm going to take my 60 millimeters of mercury and convert that to kPa. So 760 millimeters of mercury is 101.3 kPa. We have those conversion factors at the top of our problem page there. Millimeters cancel. We're going to do this and round to 3 sig digs. We had that in the previous problem. We get 7.79 kPa. Right? So minus 7.79 kPa. I now want to remember that when we are doing our subtraction rule, we're counting decimal places. So we have 1 decimal place and 2 decimal place. I put that in my calculator. I get 90.21. We are going to round that to 90.2 kPa would be the final answer on this problem. All right. So if we summarize, we see that we are going to have, comparing our two manometers, the closed manometer is indeed very, very simple. And we would simply look at what the height of the mercury is, and I would know indeed what the pressure is. For the open manometer, we have the gas pushing on one end, the air on the other, and so that H that we're able to read is actually the difference between the two. By analyzing it, we're always going to find the pressure of the gas by starting with the pressure of the air and either adding or subtracting that H, deciding on whether we want the number to be higher or lower. Okay, that's where we're going to end for today. And tomorrow we'll just do some practice on how we go about finding pressures in manometers. Okay, everybody go wash your hands. See you tomorrow.